41 setting you up. You've got one of two things you can do. This is going to be a linear combination style problem, which means you have to multiply both the top and the bottom by some scalars to eliminate one of the values. It is totally up to you to decide which variable you want to eliminate first. Notice they both have alternating signs. The x values and y values have alternating signs, so when we do eliminate them, we're going to add them together. Remember about subtraction here. Now you just make a decision. Do you want to get rid of x or do you want to get rid of y? All right. If I'm going to get rid of x, I have to get some common multiple between 2 and 5. Okay. So I multiply the top one by 5, the bottom one by 2. And I get 10x, 25y. Who is it? You can do that. You can do that too. Now, guys, I would stay away from doing negatives because you're going to screw up the sign. Okay, that's just me knowing how you guys work. I would always tend to deal with positive values or multiplying through with positives because it's less taxing of remembering that you have to distribute the negative 3 times. If you did it right, I'm not going to say you can't. I just always remind yourself when you're working with negatives. Oh, what's that? Working? Sorry, it wasn't loaded. Yeah, right? Go back to this one. Okay. Back to here. Distribute through, we get the 5 to the 17, then that's what, 85? Right. Go around again, negative 10x, minus 65, negative 20. Now, we have 3 problems, and in this case, we know that we have same coefficient opposite signs. So when I split this into 3 problems, I'm going to add them together. That eliminates my value of x. 25 and negative 14 gives me 11, 5. And then the other one is what, 65? Right. Divide it out, you get a y is 65 over 11. Okay? So if y is 65 over 11, it's just some funny fraction. Okay? Go back to the original equation. Does it matter if I use the top or the bottom one? Nope. I'll use the 2x, 5y is 17 one. That was the original. Now, remember, your calculators have a button, 5 parentheses, alpha y equals. Oops. There it goes. Sorry. Then 65 over 11. And that gives me another fraction. Now, there's a button on the calculator that you guys are going to learn to love a lot. It's the answer button. You guys know what that is? Down underneath where it says the negative button. Oops. Now, on the one side of the fraction, try not to get the calculators dropped around. I get fancy. Please don't do that. On the other side of the fraction, right, or the equation right now, you got something x plus this crummy thing equals 17, I believe. So what I would do is do 17 subtract that answer. Second negative. And it's going to give me another fraction. Now this equals 2x, correct? So now all I have to do is type in divide by 2. There's my value of x. It's again back in a crummy fraction. It's perfectly fine that you got crummy fractions because it happens. It happens all the time. Okay? So your answer, your solution set in this case would have been negative 69 over 11, comma, 325 over 11. Okay? Does that make sense? So you weren't wrong by getting crummy numbers.
Okay.
It happens.
Okay.
It happens. Okay? Yes, sir.
Yes.
Okay? Guys, ladies and gentlemen, enough with the talking. Thank you. A lot to do today. Pick one to eliminate. Doesn't matter. They're both going to be kind of ugly. X's or Y's. Again, you've got alternating signs for both of them, so I wouldn't worry about subtraction stuff. I would probably just do the top by, maybe doing 10s and 7s would be a little bit easier, as opposed to 3s and 11s. Everybody be okay with that? I'm going to do 10s and 7s. I'm going to get rid of Y's. I'll multiply the top one by 10, bottom one by 7. So I get 30x minus 70y is 200. Negative 77x plus 70y is 35. Again, 3 problems. You're adding between them because you have same coefficient, opposite signs. Add them together, they get eliminated. So 30 and negative 77 would be negative 47x is 235. Divide it out by negative 47, and I bet you get another crummy number. Or does it stay like that? Oh, even better, negative 5. Oh, I should have guessed that. So there's your value of x, which means you pick one of the first 2 equations to substitute back to. It does not matter which one you choose. So I go back to the top one. 3 times negative 5 minus 7y is 20. Well, that means I get negative 35 equals 7y, which means it's negative, positive 5 for x. Oh, yeah, sorry. So it is negative. Sorry. Yeah, negative 5. So my solution would have been negative 5, negative 5. Okay. Now, I guarantee most of you guys, if you start to get off track on these, you know what happens? Oops, let's find the right thing. You'll read part of one problem and then part of another problem. Happens all the time with these. So if you got some really crazy looking stuff and you had no idea what you did, I guarantee that you read part of question. I guarantee if you were reading between these 2 problems, sometimes people will write down the first part here and the second part here. That happens all the time. So if you got really screwed up and not knowing what happened, you get really weird numbers, I bet you that happened. And it's really hard to do this, especially with Chromebooks, because on Chromebooks, it's really hard to just go up and cover up something, because you really can't. Okay? All right. Save it. We'll continue on adding to this stuff with 3.3 because what we're doing today, actually, what we're going to do between today and into tomorrow is we're going to continue kind of doing the same thing with, but yet we're going to graph. Now, I know that I had written out originally that we're going to start the actual word problems themselves on Friday. All right. Then I had this premonition of that it's a Friday, and I was about to give you half a dozen word problems to do, and then I realized there's no way on God's green earth you were going to do that over the weekend. So we're going to spend extra time over like the half day tomorrow with systems, and then in Friday to build more of what we call constraints. We'll spend extra time building constraints and systems prior to having to do them with word problems. So we're just going to push off word problems by a day, which I'm sure you're all horribly, horribly heartbroken on. Also, when it came to the word problems out of the actual textbook themselves, that's the right one. Some of the problems that people were asking that were in their file here, excuse me. Some of these word problems that were written out, they get a little weird if you're not careful. Just real quick, 54, you're selling boxes. You're selling, your business selling boxes of hand-painted greeting cards. To get started, you spend $36 on paints and paintbrushes that you need, and a box of playing cards is $3.50. You paint them, then you sell them for $5. How many do you have to sell before you break even? Is what that basically means. So, have any of you guys ever had a lemonade stand? Okay, when you had a lemonade stand, I'll put a little accent in it, make it sound like it's fancy. So if you had yourself a little lemonade stand, lemonade, and you're selling it for 50 cents a cup, okay? Let's say that your parents gave you $15 for a startup. Yes, sir. I can't hear you. Well, what if your parents made you pay them back what they gave you? Well, let's say your parents are like, the way that I grew up, you owe them the $10 startup fee. All right, so they invested in your company, and they're going to be nice enough to invest in your company and not take a cut of it by not asking for a percentage after the initial investment. Normally, people would get a cut of percentage after investment. That's the whole point of investment. So your parents give you $10 to start up because, packets of high C is cheap and you happen to scrounge up enough cups lying around the house to be able to use them. Okay? So you get going, and it's basically asking you how many cups of lemonade you have to sell before you break even with your parents and everything else that you're making money. Stuff like that's pretty easy to figure out, right? That problem is the same thing. What's different here is that instead of lemonade startup costs, you're spending $36 on paint and paintbrushes. Also, you're spending $3.50 per box of greeting cards, blank ones. You're going to turn around and sell those greeting cards for $5 a piece. Where does your initial setup equal what your sales are? That's what that means. Okay? That one's a lot goofier than some of the other ones where you wind up with a very straightforward, 2 of these plus 3 of these equals this much. You buy 8 apples and 7 oranges for $12, and then each apple and orange costs how much, and things like that. Yes, guys? Yeah, it's kind of what you get into here as you start moving it, because that's what it is. You can write it. It winds up bringing that over. You get 1.5b minus 36, where you break even. It's kind of what you're looking at. Yep. And these first few word problems you had on here were kind of straightforward. Okay. I'd be selling first hour. If you hadn't had a chance to finish those through, make sure you go through those today, because with the half day tomorrow, we'll have 25 minutes of going over what we did today, And we can re-hit those quick setups on those workups, those 4. I've already shown you how to set up one, so there's only 3 left. Those other 3 are really quick. Believe me, they're a lot easier than this first one. This first one was weird because of the wording. Okay. So let's finish out and go into 3.3 then. What I want to do today is talk about systems of inequalities. The only thing that is different between what we've done with a single inequality versus what we call a system of inequalities is that we're going to graph 2 of them on one piece of graph paper. That is the only difference between what we've done in the past versus today. We are going to look at a shaded overlap area. You're going to want to grab a couple of these. Honestly, we're going to have some that we'll use graph paper for and some that we will not use graph paper for. I thought that the first example to have a little piece of graph paper wouldn't be a bad idea. But then you really don't need it. Now, one of the things that we did when we had linear equations a couple of weeks ago is that we had one of the forms called standard form. And if you remember, standard form was when you were able to have that ax plus by equals c, and you could cover and solve to get your x and your y intercepts respectively. Well, remember, what happens is you can do the exact same thing. You can do the exact same thing with inequalities, and it doesn't change. Okay? It doesn't change. So, for example, here, the first one I'm going to do with a piece of graph paper, so if you've got graph paper, great. If you don't, no big deal, is do a cover solve as far as what your intercepts are. Remember, when you're doing cover solve, easy. When we're doing cover solve, if I cover up x, where's my y-intercept? It's at -2, good. If I cover up y, where's my x-intercept? 2/3, right? Now, does it matter that it's 2/3? Did you kind of fudge and figure out where 2/3 is? Here-ish? Now, going back to the problem then, when I connect those 2 dots, is it a solid or a dotted line? Solid. Yep, it's solid because of the less than or equal to. So I connect them. Like that. Did that graph or that line go through the origin? Nope. Now remember, when you have an inequality graph, what it does is that it splits your graph into what are called 2 separate half planes. One half of the plane, or in this case the xy coordinate system, is true. The other half of the xy coordinate system is false. What you do is you use what's called a test point. Obviously, the easiest test point to always use is going to be the ordered pair of 0, 0. Can I use 17 and -4 if I wanted to? Yes, if it's not on the line, it's fine. But what's 0 minus 0? Is 0 less than 2? Yes. So that means we're going to cover the truth. If it's true at the origin, we cover the truth. Now, remember, just try and get used to drawing lines like that. The reason I want you to just draw lines like that is so that you're not overly shady. Because eventually what we're going to need to do is figure out where intersection occurs. And how do you find intersection? Well, we're going to use systems of equations. Do the same thing for the second one. My x-intercept for my second equation is where? 1. Y-intercept at? 2. Each color is at 1. 2. Do those two get a solid or a dotted line? It's solid. Did it go through the origin? Nope. It did not, so I'm going to use that ordered pair again of 0, 0 as my test point to check and see if it's true or false. What is 2 times 0? 0. What is 0 plus 0? 0. Is 0 smaller than or equal to 2? Yes. So is it true or false? True. And we always want to cover the truth. So what happens here is that you get this overlapped region. Yeah, you get this overlapped region in here. Now, I know I'm just kind of drawing that in. You don't need to do that, but that's the kind of stuff that we're going to be doing with systems of inequalities. They're able to create regions. That is kind of a better way of writing it. Now, what that means is any point that I choose in here, in this double shaded region, would be a solution to the inequality system. Every point would work. If I use the ordered pair at -10 and 0, that would be a solution to both equations or inequalities as true statements. That's what that means. We're trying to figure out not just where the two lines would intersect each other, what region becomes what we call, have you ever heard the word feasible? It's a feasible region. Okay, it's a feasible region. Okay? So really, it's the same thing we did a couple days ago, but you're putting two on one sheet. In a nutshell. Okay? All right. Well, no. Do you think it changes at all if you're in slope-intercept form? Nope. Not at all. It doesn't change at all. Actually, I've always thought that graphing in slope-intercept form is really easy because it's the first way that you guys learn. So if you have the inequalities, y is greater than or equal to -3x minus 1, and y is less than x plus 2, what we're doing is just going to graph both of them on the same grid. We graph both of them on the same grid and figure out where their overlap occurs, or if they don't have overlap. I'm not on the laptop. You can close it. Thanks. What's your slope and y-intercept? -1 is slope up. Well, yeah. Well, my -1 is my y-intercept. That's my slope. Right. Start at -1. Or up, left. Connecting those two is in a solid, or those 3 or 4, however many there are, it's going to be a solid or a dotted line. It's going to be solid because it's greater than or equal to. Did we go through the origin? No, we didn't. Plus, remember that if you went through the origin, you'd wind up with an intercept there at 0. Excuse me. So check your ordered pairs. Is 0 bigger than or equal to -3 times 0 minus 1? So is 0 bigger than -1? Yes. So it is true going towards the right, because that's where 0, 0 is. Yeah, if you've got extra colors, this is an awesome section, these next couple of sections. If you've got multiple colors, to use multiple colors. It is a great thing. You know, no big deal. Just beat somebody up and take their crayons. The next one, you have a slope of 1 and a y-intercept of 2. So you start at 2. All funkified there. And then between those, is it going to be a solid or a dotted line? It's going to be dotted. Very good. I really liked on the quizzes, some of you guys realized that you drew a solid line, but yet it was supposed to be dotted, and you wrote dotted. And then obviously again, they go through the origin. Is 0 smaller than 2? Yes. So we move down here, and then here comes our shaded region off in this character. You are trying to create shaded region. All right? Does any of this change if you don't use graph paper? No. None of this changes whatsoever if you are not using graph paper. So let's not use graph paper. Let's look at a feasibility region and understand exactly what they are looking for. That's not on our phones. Now, when I have these values like this, when I have regions, a lot of times you're going to start to see x is greater than or equal to 0, y is greater than or equal to 0. It's telling you that something is occurring on an xy coordinate system in a certain quadrant. Guess what quadrants are? How many of them are there? Okay. What's this one? One of them. Very good. What number is the one to the left? Okay. Now, remember, when you're dealing with ordered pairs have specific values within each of these quadrants. Our x and y values are both positive here. What becomes negative in your second quadrant? Negative x, positive y, negative, negative, and positive, negative. Now, just so that you know that I have said this at some point in time before you look at me again when, like you're really crazy in February, cosine and sine have positive, negative values depending on which quadrant they land within as well. And it follows the same pattern as x and y. You know why? What comes first in the alphabet, cosine or sine? Cosine. What comes first in the alphabet, x or y? X. The sign, S-I-G-N, it coincides with the plus minuses of the signs, S-I-G-N, of the XY coordinate system. This is one of the things that will come back to haunt us in February-ish when we get to unit circle. When we get to unit circles and have to deal with finding the sine, cosine, and tangent values. Yes, sir. You can put in, I did this the first hour, and I told them to put an alert mid-February. Hey, Murphy told us about sines and cosines and where they're positive and negative. I guarantee you it'll come back around then. The video will be finished up later, and I got a couple more examples. You're probably good to go if you need to. Otherwise, just watch it up, okay? Julio. All right, so when we get to stuff like this, you have to remember where certain values occur. What I mean is, where is x positive? When it's greater than 0. But now, in terms of visually, if you're looking at an xy coordinate system, what direction is it? It's going to the right. X values being positive go to the right. When you have this direction are positive values of x. Where are positive values of y? Upward. Now, these are still positive down here. These are positive values of y. Where do they overlap? In quadrant 1. So this little bit tells you what kind of a problem you have. You have a quadrant 1 problem. So this is where you're going to start to visualize what does it mean to be positive? What does it mean to be greater than 0? What does it mean to be x is greater than 0, y is greater than 0? That means I'm a quadrant 1 problem, and I'm only looking at that specific region. That's that first idea of how we're going to start to look at what are called constraints. Because now I have a third system I have to put in there that's written in standard form. 4x plus 3y is less than 24. Do your covers and solves. What are your x and y intercepts? I have an x-intercept if I cover that up at 6 and y-intercept at 8. So can I just say, here's 6 comma 0, because that's what the order pair is, and here's 0 comma 8, and then I just have to connect the dots. Yeah, it was less than or equal to. That's why I made it a solid. Okay, sorry, I didn't say that out loud. Now I have to think about what direction do I shade that? Do I shade it towards 0 or away from 0? I shade it towards 0. Very good, because what's 4 times 0? What's 3 times 0? What's 0 plus 0? Is 0 smaller than 24? Yes. So what you've created here is this shaded region that creates a triangle. What's the order pair here? What's the length from here to here? Very good. It's 10. It's a 3, 4, 5 triangle. Hey, welcome back to Remembering Stuff About Geometry, ladies and gentlemen. Yes, we do rear exactly ahead from time to time. About what? Oh, geometry circles back through, right? It all circles back through. Okay? So yes. Oh, we'll do proofs eventually. Oh yeah.
Okay, it's time to go.
Yeah, ladies and gentlemen. We'll do that. That's it. Algebraic trigonometric proof. Using trigonometric identities to prove and simplify. THAT space OUT. All right. Anyway, does that change? Does this change at all? Let's do this. Y is less than 2x plus 3. Will it change any if I'm looking at it with only one constraint of an x or a y versus with other two linears? No, it really doesn't. But think of it this way. What two quadrants does is x greater than or equal to 0? 1 and 4. Remember, quadrants go counterclockwise, so it's 1 and 4. So this one, when you're looking at by this first information, then I'm looking at 1 and 4. Because x is greater than 0 going this way, here and here. Okay? The next two steps, y is greater than 2x plus, or 2x minus 1, excuse me. That's my y-intercept. -1. Can I just say that it's about here? And then I'll have to go up. 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. So on and so on. Between those, do I connect the dot or dotted? Dotted. So here's 1, 0, 1, 2, 4, 5. I'm just making sure I have my spots on there. And now go in the other direction. Oh, sorry. Shaded. What is 0 smaller than 3? Yes. So that one's going to be shaded coming inward here. Okay. Shaded inward there. Now if I go the other direction, I have to start where? At 3, what's my slope? 2. So these two lines are parallel to one another because they share the same slope. Start at 3, 1, 2, 3, up 2, over 1, up 2, over 1. And those would be dotted as well. Obviously, it doesn't go through the origin, but is 0 smaller than 3? Yes. So that one would wind up into here, like that. But does it pass that, or does it pass, excuse me, does it pass that other dotted line? No, it doesn't, because that's got, that 2x minus 1 is a bottom end, the 2x plus 3 is a top end. So what it's doing is creating this little range in between. There's no lid on it, so there's no maximum value, but it's creating that little wedge there. And it's something, if you have it drawn, out, it's kind of like this. It would kind of look like that if you shaded it out. It gets us in the intermediate range. What's that? Because this is the overlap region that it's true for both. And that's how that works. Let's try another one before we run out of too much time. Last one before we run out of time here, because I just want to show this one real fast. Y equals a number is what kind of a line? Straight. Yes, it's straight. And straight in which direction? Horizontal. Very good. X equals a number is what kind? Vertical. Very good. Very good. Now, just thinking-wise, this tells me I'm going to have two verticals, two horizontals, correct? What is that going to make? It makes some sort of a rectangle, isn't it? Because anywhere a vertical and a horizontal run into each other, it is perpendicular. Okay. So if I have y equals -3, can I just say that y equals -3 here? Can I say that y equals 5 here? I'm sorry, less than or equal to 5. Means I'm going this direction and this direction. I'm in that sandwich area, not down by root 34. Sandwich area. Is it there? Get it? Greater than or equal to, well, this is the line. Oh, I'm sorry. Got to do that. Thank you. So I'm going in between there. Here's x is greater than or equal to -2, so I'm going this way. X is less than or equal to 5. I wrote 5, right? No, 4. And I'm going this way. Oh, yeah, it's no, it's just my brain. You have how many points of interest here? 4 of them. You have 4 points of intersection. What are your ordered pairs? What's the x value here? On the lower right, what's your x value? What's your y value? Bless you. Oops. That was negative. I meant -2. I'm sorry. 2. Sorry, I wanted to fly. I had to fly through that real quick there. But what I'm looking at here is, eventually, within the next day and a half, you're going to be finding those points of inflection where they change direction, where they run into each other via systems. This is the easiest one when you have rectangles, because you have your x and y values you know what you run into. I did post the calendar the 9 or so I think I put on there. Let's see if I can find it. 3. Oh, I have to add the attachment. I apologize. I'm going to add the attachment to the PDF file real quick, and I've got those 9 questions. You can or cannot use graph paper. I think these first few would be a lot easier to use graph paper. So make sure you type something down. I got a little bit more here. It's just graphic. I didn't think you were that big of a jerk. There you go. It should be saved out there now for you. I apologize. I thought I already had that PDF on there. So you guys are good to go on those. We'll go through that tomorrow. We'll start talking a little bit more about constraints. We will also talk about the quizzes tomorrow as well, since I got all those down